This lever has a short end and a long end, right? But the whole thing comes out to 1 meter. So the idea being, on this side, it's kind of like you have an output distance. It's not really indicated how far around this rotates, but the idea being that the fulcrum is the point which the lever rotates around. So we have this side that rotates a little bit and this side that rotates a lot more. So you can kind of treat this like an input and an output, right? This is the output side. This is the input side. And our lever is made of one arm that is on the output side. I'm going to go ahead and write this as DO, even though that's not really the distance traveled by the lever, but it is the length on that side. So that's your 0.25. Again, if you were one of those folks that wasn't able to grab this and put it in your brain and get something out, then I would listen now so that you have it. Okay. There's going to be an output distance and an input distance here. I know that this is the input side of the lever. Think about it like this. This is part one of this problem. How long is the other side of this lever? The whole thing's a meter. One part is 0.25. The other part is 0.75. Okay. So now that we have that, you can actually calculate the mechanical advantage of this lever. There's two ways that you can calculate advantage. One of them is to compare the distances. So this would be like the input distance over the output distance. The other way you can calculate mechanical advantage is to compare the forces, the force out compared to the force in. We can do this one right now. So how many times will this lever multiply your force? What's the mechanical advantage of this lever? Is it 3 times bigger on this side than that side? Yes, it is. It's exactly like lever number 2 off my demonstration piece. So the mechanical advantage of this thing is 3. That means it multiplies your force by 3 when you use it, or a load that is on it will feel 1/3 as heavy as it should, right? The second thing you've got to do is you've got to figure out what the actual force is. 120 kilograms is given as a mass, not a force. So what's the weight of 120 kilograms? Let's just keep gravity at a nice easy 10 today. 1,200 newtons. Okay, so 120 kilograms would weigh 120 newtons. Or sorry, 100. Yeah, what you said. There you go, 1,200. That's what I was trying to do. All right, that's the weight of this, right? And if this was a 1-to-1 lever, or if this was a straight lift, 1,200 is how hard you would pull up to make this thing lift, right? But this thing takes your force and cuts it in 3. It's a factor of 3 longer, which means it has an advantage of 3. So that means that your work is multiplied by 3 when you put it in. So how hard do you have to push down on a lever with an advantage of 3 to get out 1,200? It goes kind of like this. Your force in times advantage is going to be that force out, right? It's going to multiply your force. She said 400. Do y'all agree? If it multiplies you by 3 and you need 1,200 out of it, what times 3 is 1,200? 400. So this machine having a mechanical advantage of 3 means if you push down with 400 newtons, you can lift something that is 3 times larger, 1,200 newtons. We call it G10 instead of 9.81.